to learn how to solve some equations that involve the absolute value function. Now remember, the way absolute value works is, well, one way it works is a distance measurement device. If you say the absolute value of 5 is equal to 5, that's because if you look on the real number line, you'll find that 5 is 5 units, whatever type of unit you decide to measure with. 5 is 5 units from the origin. And since absolute value is measuring direction, that's where we get that answer. But also, negative 5 is also 5 units from the origin. Therefore, the absolute value of negative 5 is also 5, since, again, absolute value measures distance, doesn't really pay any attention to direction. So when we get an equation to solve, we'll start with a very simple one, like absolute value of x equaling 12. You have to remember that since we're measuring distance without looking at direction, that we're going to have an answer to the left and to the right, so to speak. So what we will do is, remembering what happened over here on the number line, is we will say that this implies x could be 12, or x could have been negative 12. And this plus 12 minus 12 approach is what we will take from here on out. So when we run into an equation that's slightly more complicated, like absolute value of x plus 3 equaling 7, again remembering what happened on the number line with the negative 5 on the left and the positive 5 on the right, we will say that that must mean that x plus 3 could be 7, or perhaps x plus 3 could be negative 7. And again, remember, this is an or type relationship. So we've taken the one absolute value equation, broken it down into two fairly simple linear equations. So over here I can subtract 3 from both sides and get that x equals 4. Or if I subtract 3 on both sides over here, I get that x equals negative 10. So again, looking at a answer on one on the right hand side and one on the left hand side, even though they won't always be on the left and right hand side of the origin, they'll be to the left and to the right of each other. Alright, so trying this again, if we had absolute value of x minus 4 equaling 8, remember that that means x minus 4 could be 8, or perhaps x minus 4 could have been negative 8. Again, the one absolute value equation becomes two linears. I add 4 to both sides to get x equals 12. Add 4 to both sides on this one to get x equal negative 4. Alright, now let's try that one more time. Let's look at the absolute value of x plus 1 equaling 0. Now in a special case like this, we will say that x plus 1 equals 0. Or, now when we've tried to make the second statement though, we try almost as if we're going to write down like the opposite of 0. But 0 doesn't have an opposite. So this is the one case in which there won't be two answers. We will get x equaling negative 1, and that'll be our only solution. Now something that I haven't been doing, just for the sake of time, is taking all these answers and plugging them back in to make sure they actually work. That's something that would be a very good idea, because on occasion you get some problems where one answer doesn't work, or the other one doesn't work, or perhaps neither one is going to work. If we had, for example, the absolute value of x plus 9 equaling negative 2, if you didn't notice at first glance something was wrong with this question, you could go on to say, well, that means x plus 9 equals negative 2, or x plus 9 equal positive 2, using the plus or minus technique. Subtracting 9, we get x equal negative 11, And subtracting 9 again, I get x equal -7. But what we would discover if we were to plug these numbers back in, for example, -11 plus 9 is -2. Absolute value of -2 would be +2. We would discover that answer didn't work. Plugging this one back in, absolute value of -7 plus 9 is the absolute value of 2, which is 2. Again, it doesn't work. Now, where we should have known something went wrong is when we saw absolute value equaling a negative number. We know that that can't happen, so we should have known that that problem could have no solution. Now let's look at a couple more examples, perhaps. Let's look at, for example, the absolute value of 2x plus 1 equaling 6. We will break that down into a 2x plus 1 equals 6 and a 2x plus 1 equaling -6. And remember, it's an OR statement. Now I'm going to do the first step in these the same as I did before. I'll subtract 1 from both sides, and I get that 2x equals 5. But in this one, because of the 2 coefficient, there's one more step to take, and that would be dividing by 2. And you could write this, if you wanted to, as 2 1/2 or 2.5, however you want, that you could write it either way. Same story over here. I'll get 2x equaling -7. When I divide by 2, I can get -7 halves, -3.5, -3 1/2, however you want to write it. I believe you'll find both these answers work when you plug them back in. Now, we can approach these problems graphically, as a matter of fact. Going back to, say, the second one we did, absolute value of x plus 3 equaling 7, we can go to the calculator, and we go into our y equal to, and absolute value is found by hitting the math button, going over the number, and option number 1 is absolute value. And remember, it's the absolute value of x plus 3 that we want. So I'll just put an x plus 3 into those parentheses and hit enter. Also remember, we wanted it to be set equal to 7. And so I'll type in the 7. And when we graph it, you see the typical V shape of the absolute value function, and you see the horizontal line, which represents 7, coming through the picture. And so we're going to want to move over. I'll look for that right-hand solution first by hitting trace, moving to the right. And we do see that the answer is somewhere around, well, 3.8, 4.0, something like that. So I believe that would justify that our answer of 4 was correct. As a matter of fact, we can go to the Calculate menu and look for, under number 5, an intersection. First curve was the absolute value function. Second curve was the 7. My guess is the spot that I've pointed at. And the calculator verifies the answer is, in fact, as you see here, a 4. Now, looking for the other answer, I will go to the left, moving over quite a ways with my pointer. And it takes a minute to get there for some of these solutions. We can see almost on the screen where they're coming together. And what I think I will do to get a better look at that is do a zoom in. Now, I'll zoom in at this point, since I moved the pointer around. Should take me to the spot that I was trying to point at. There it is. So, again, going to the Calculate menu, looking for an intersection. First curve was the absolute value function. Second curve was the straight line. This is my new guess because I've now pointed at it. And it verifies that our other answer was -10, which, as you recall, 4 and -10 were the answers we found by paper. So you can do this on pencil and paper. You can do this on the calculator, and they'll both give you the same results, even though the calculator requires a little bit more practice.